Hello everybody, we're going to talk about graphing sine and cosine functions, and we're going to start off with just the basics. We recall from a unit circle standpoint that if we wanted to find out something about the sine or cosine of the function, we could look at the x and y coordinate as we associate it with some arc length t along the curve. So let's get that arc length t right here. We say if there's an arc length t right here, then the x coordinate was associated with the cosine of the angle, and I'll put that here in green. So this is our cosine of the arc length t, while the sine of the function was associated with the y values. So y was associated with the sine of that arc length t. Now we can use that if we imagine that that arc length t is somehow unrolled and flattened along this horizontal axis right here, and we look what happens to the values of sine of t as we progress. For instance, we know that when we're at 0 radians of rotation, sine of 0 was equal to 0. We also know that if we were to continue going, we could probably mark out a few values. For example, we know that the sine of pi over 6 is equal to 1/2. That's pretty close up here. And that the sine of pi over 3 would have been equal to square root of 3 over 2. It's about 0.8 or so, right here, about 0.866. And then at pi over 2, right, the y value was 1. So right up here, we could say, well, at pi over 2, then we get 1. Now, if we follow this pattern around, and let's just go to the major positions right here, pi over 2, and at pi over, well, pi, and then 3 pi over 2 here, and then 2 pi. Look at what happens to the y values as we go around. The y value here, in this case, is equal to 0 at pi. The y value at 3 pi over 2 is negative 1. So I'll go down here to negative 1. 3 pi over 2 is at negative 1. And then if we go around to 2 pi, the y value is back to 0 again. And if we follow these patterns around, here's what it looks like. We've got this graph that comes up to positive 1 at pi over 2, then follows the same pattern down at pi, and then at 3 pi over 2 becomes equal to negative 1, and then at 2 pi returns back to 0, and that pattern's going to start all over again. Now, we can say some of the same things about cosine. For example, the cosine at 0, right here in this position, we know that the cosine is equal to 0. Sorry, the cosine is equal to 1, because we know that the cosine of 0 is equal to 1, right? That's our coordinate point right here. 1, 0. Using all kinds of colors here, but hopefully you get the idea. So we follow those patterns around here for cosine. We note that cosine always goes with the first coordinate. So in our coordinate right here, negative 1, 0. At our first coordinate here, 0, negative 1. At our first coordinate here, 1, 0 again at 2 pi, which is, well, 0. So if we were to follow the cosine graph around, we would say, well, at x equals 0, y is equal to 1 this time, right? At the arc length of pi over 2, the x coordinate, the cosine is equal to 0. At pi, the cosine is equal to negative 1. At 3 pi over 2, the cosine is equal to 0 again. And at 2 pi, we're back to 1. And then the pattern starts repeating again. So we get this one cycle of our sine and cosine function that looks something like this. And so if we're looking at it, these two functions, they actually do look pretty similar. And it's almost as if I could take this function right here, this cosine function, and turn this curve around, and it looks kind of like I'm following the x curve, right, as it goes around. You see that in green right here. We're just getting the y value that goes along with every arc length, starting at 0. But let's bring this back to where it belongs here. drag this back up a little bit here. Ooh, boom. And put it back in place here. There we go. Okay, so this is our illustration of our basic sine and cosine function graphs. More to come.